Good morning, students. It is chapter number 4, lecture number 6 for 11th physics students. In this lecture, we will discuss about the circular motion. In last lecture, we started the circular motion. We discussed what is the angular velocity. And I asked one question. If a particle is moving in circular path with constant speed, then why there should be acceleration? This is circular path, a particle is moving, at any time this particle is here. This is direction of motion at that point. At any point, the direction of motion will be tangent to this circumference. Now it will travel some distance, it will reach here from point A to point B. This is small distance traveled in small time interval. That will be direction. So there is some angle between these two. This is V, it is also V. So you can say if I drop it here, after some time it was, this is initial, after some time this is the direction. This velocity is V. If I take its component along this direction, it should be V cos theta. This angle is theta. So this component should be V cos theta, and we know that value of theta is, cos theta is maximum when theta is 0, and that value is 1. So if this angle will be 0, then this component will be 1. It will be V because cos theta will be 1. So component will be V cos theta, that is V. If this theta has any value except 0, then value of cos theta will be less than 1. So this V cos theta component should be less than V, but it is V. This velocity should be less than V, but it is V. It means this velocity is increasing. It means it is acceleration. So there will be acceleration if a particle moves in a circular path with constant speed. Now we will find out relation between linear velocity and angular velocity, and we will calculate what will be the acceleration, what will be direction of the acceleration. First we are calculating velocity. Suppose this particle reaches from point A to B, it travels angle delta theta in small interval of time delta t. In small interval of time delta t, it travels angle delta theta. So what will be velocity? Velocity will be arc AB, that is this distance AB, divided by time delta t, because it reaches from point A to B in delta t time. So that will be the velocity. Now in this triangle, suppose it is O origin, OAB. If theta is very small, in that case arc AB upon radius will be equal to this theta. It is trigonometrical identity. So arc AB will be equal to R delta theta. So that will be value of arc AB. So what will be velocity? So velocity will be, substitute the value of AB, which is R delta theta divided by delta t. Change in angle upon change in time. Delta theta upon delta t, that will be angular velocity. So this velocity will be equal to R, angular velocity is denoted by omega. So this velocity will be R omega. So this is the relation between linear velocity, angular velocity and radius of the circle. So if you know the radius and if you know the angular velocity, then you can calculate the linear velocity. Now we will find out what will be acceleration. Acceleration is change in velocity upon change in time. So before that we will find out what will be change in velocity. Suppose change in velocity is delta v. So delta v will be final velocity minus initial velocity. Initially particle was moving in this direction, so that was v. After some time this is velocity, so that will be final velocity. This one will be initial velocity. This one initial, this one is final. I am drawing a line parallel to this line. I am drawing it here. This is v initial. Now draw a line parallel to this. That is final velocity. This length will be equal to this length because magnitude of velocity is same. Now we want to calculate Vf minus Vi. This is Vf, this is Vi. So what will be minus Vi? If I just reverse the direction of this Vi, that will become minus Vi. So now I am reversing the direction. So if I reverse this direction, it will become minus Vi. Our aim is to calculate a Vf minus Vi. Now it is Vf minus Vi. These are two vectors. They are in same order. This is the direction, this is the direction. Their direction is same. Now this is the third side. Orders would be opposite according to triangle law of vector addition. These two sides of this triangle are representing two vectors in magnitude and direction. The resultant will be given by the third side taken in opposite direction. For these two vectors, order was same. Now this order will be reversed. It is delta v. Change in velocity. This angle is delta theta. So delta v will be Vf minus Vi. So this direction, this is the magnitude, this length is the magnitude, and this is the direction of delta v, change in velocity. So it is toward the center. So acceleration will be toward the center of the circle if particle moves in a circular path with constant speed. Acceleration will always be toward the center of the circle in that case. Now we will find out what will be the acceleration. This side by this side, delta v upon, whether I say Vf or Vi, because magnitude of Vf is equal to magnitude of Vi is equal to V. So this magnitude is V, so this side upon this side, so delta V upon V. Because magnitude of Vf is equal to magnitude of Vi, particle is moving with constant speed. So magnitude of velocity is not changing. It will be equal to this angle, delta theta. It is trigonometrical identity. If this distance will be very, very small, so in that case this angle will be almost 90 degree. So this side by this side, that will be sine theta, and sine theta is equal to theta if theta tends to 0. If theta is very small, in that case sine theta will be equal to theta. So delta V will be equal to V delta theta. Our aim is to calculate acceleration. This change in velocity is taking place in dt time, delta t time. So what will be acceleration? Change in velocity upon change in time. So if I divide this equation by delta t, then we will get the acceleration. So now I am dividing this equation by delta t. Divide this equation by delta t both sides. Change in velocity upon change in time, that is acceleration. V. Change in angle upon change in time. Change in angle upon change in time, that is angular velocity. So A is equal to V omega. So acceleration will be equal to velocity into angular velocity. Now we can substitute the value of v. We calculated v was omega r, so it will become omega r into omega, that is omega square r. So acceleration will be equal to v omega, or it will be equal to omega square r, or acceleration is omega square r. Now I am multiplying it by r, dividing by c. So it is omega square r square by r. But v is equal to omega r, so this term will become v square. So a is equal to v square by r. So acceleration will be v square upon r. So that will be magnitude of the acceleration, and it will be toward the center of the circle. That was the graphical method. We will use calculus method as well to calculate the acceleration and velocity, and we will find out the exact angle. What will be direction of acceleration, what will be direction of velocity. Now we will calculate velocity and acceleration in case of circular motion using calculus method. But before that, I will take a very small topic which will be used in this derivative part. Coordinates are x and y. This angle is theta. So what will be angle of this vector with x-axis? I want to find angle of this vector with this x-axis. Suppose this triangle is OAB. So in triangle OAB, tangent theta, it is height upon base. This height is y, this base is x. Because coordinates are x and y, so it is x and it is y. So tangent theta will be y by x. Y by x. So if you know the coordinates of the particle at any time and you want to calculate what will be angle of that vector with the x-axis, so that angle, tangent of that angle will be y by x. This property will be used in this topic. Now suppose this is circular path. Particle starts from this point A, and it is traveling along the circular path with angular velocity omega. After some time, it reaches at point B. Coordinates at point B are x and y. This angle is omega t. Omega is angular velocity, so in t time it will travel omega t angle, so that will be omega t. R is the radius of the circle. From this point draw perpendicular. Suppose it is origin O. This point is P. Our aim is to calculate velocity and acceleration and their directions. What will be magnitude and direction of velocity and what will be magnitude and direction of the acceleration. We want to calculate that. Position vector of this point, that is coordinates are x, y, so position vector r, that will be given by xi plus yj. X along x-axis, y along y-axis. I means unit vector along x-axis, j means unit vector along y-axis. So it is a position vector, and we have studied that rate of change of velocity, rate of change of position is velocity and rate of change of velocity is acceleration. So we will use that property. So first of all, we will substitute the value of x and y in this equation. In triangle OPB, sin theta is equal to height upon hypotenuse y upon r. So y will be equal to r sin theta. Similarly, cos theta will be x by r, so x will be r cos theta. So y is r sin theta and x is equal to r cos theta. And because in this case angle is omega t, so this theta will change to omega t. This angle is omega t, so it will be y will be r sin omega t and x will be r cos omega t. Now we will substitute the value of x and y in this equation, in first equation. Suppose I say it is equation number 1. We will substitute the value of x and y. So what will we get? R is equal to r cos omega t I plus r sin omega t j. That will be the position vector. Now we want to calculate velocity. Velocity is dr by dt. So it will be d by dt of r. So d upon dt of this r, which is r cos omega t I plus r sin omega t j. We will differentiate this equation. R constant, radius, it is constant, so you can write it as it is. Differentiation of cos theta, we have studied it will be minus sin theta, so this sign will become negative. Sin omega t. Differentiation of omega t is omega, so it will be multiplied by this omega. And direction is along x-axis, so that will be I. Plus this r as it is. Differentiation of sin theta is cos theta. So sin omega t, it will be cos omega t. And differentiation of omega t is omega, so it will be multiplied by omega. It is along y-axis, that is along j. So that will be the velocity. This is the x component of the velocity, it is y component of the velocity. Now we know component along x-axis. What is component along y-axis? You can say two vectors, one along x-axis, second along y-axis. So what will be resultant? Magnitude of the resultant. Magnitude will be a square plus b square plus twice ab cos 90, because angle between x and y-axis is 90 degree and cos 90 is 0. So what will be magnitude of the velocity? That will be a square plus b square. Because a square plus b square plus twice ab cos 90, so cos 90 is 0, so last term will become 0. Only square of first plus square of second, it's under root. So velocity will be square of first, which is r square omega square sin square omega t plus square of second r square omega square cos square omega t. Now r square omega square is common, you can take it outside because it is under root, so outside it will be r omega. In the bracket it will be sin square omega t plus cos square omega t, and sin square omega t plus cos square omega t is equal to 1. So V will be equal to r omega. So velocity will be equal to r omega. That will be magnitude of the velocity. Now we will find out what will be direction of this velocity. So we will calculate what will be angle of this velocity with the x-axis, and I just told you angle with the x-axis, tangent of angle with the x-axis is given by y by x, y coordinate divided by x coordinate. Suppose angle with the x-axis is theta, angle of this velocity with the x-axis is theta, so tangent theta will be y coordinate upon x coordinate. Y coordinate is r omega cos omega t upon x coordinate is minus r omega sin omega t. This r omega will be cancelled. It will be minus cos by sin, that is cot. So it will be minus cot omega t, which is equal to tangent omega t plus pi by 2. Pi by 2 means 90 degree. Tangent 90 plus theta is equal to cot theta. Tangent 90 plus theta is equal to minus cot theta. So if I compare these two, what is theta? Theta is omega t plus pi by 2, where theta is angle between velocity and x-axis. This is x-axis, this angle is omega t plus 90 degrees, so draw perpendicular on this omega t, but this particle was moving here, so draw perpendicular on this line. That will be direction of motion. Perpendicular on radius, this line is radius. This line is a radius and it is perpendicular on this, it means it will be tangent to the circumference. So velocity will be tangent to the circumference. So we have calculated magnitude of the velocity and direction of the velocity. Now we will find out what will be magnitude and direction of the acceleration. That was velocity, and we know that acceleration is dv by dt, change in velocity upon change in time, that is acceleration. So it will be equal to d upon dt of velocity, which is minus r omega sin omega t along x-axis plus r omega cos omega t along y-axis. We will differentiate it. This minus sin r omega, differentiation of sin theta is cos theta, so sin omega t, that will become cos omega t. And differentiation of omega t is omega, so it will become omega into omega, omega square. So minus r omega square cos omega t, direction was along x-axis. Now differentiation of cos theta is minus sin theta, so this sin will become minus this r omega as it is, cos omega t minus sin omega t, and differentiation of omega t is omega, so that will become omega square, and it is along y-axis. So acceleration is given by minus r omega square cos omega t I minus r omega square sin omega t z. So this is the acceleration. Now we will find out what will be its magnitude and what will be its direction. For magnitude, same procedure. This component is along x-axis, this component is along y-axis. So there are two vectors, one is along x-axis, second is along y-axis, angle between them will be 90 degree. So what will be resultant? It will be equal to under root of square of the component along x-axis plus square of the component along y-axis. Because a square plus b square plus twice ab cos 90. Cos 90 is 0, so that term will become 0. So what will be magnitude of acceleration? Under root of square of first, so it will be r square omega 4 cos square omega t plus r square omega 4 sin square omega t. Now r square omega 4 is common. You can take it outside. So when I will take it outside, because it is under root, so it will become r omega square. And what will be in the square root? It will be cos square omega t plus sin square omega t. And cos square omega t plus sin square omega t is equal to 1. So acceleration will be r omega square. After that you can substitute value of omega, which was v by r. So in different forms you can convert it. So that will be magnitude of the acceleration. A is equal to r omega square. Now question is, what will be direction? So now we will find out direction. Suppose this acceleration makes an angle theta with the x-axis. So what will be tangent theta? Before that I will write the equation for acceleration. Equation of acceleration was minus r omega square cos omega t I minus r omega square sin omega t g. That was the equation. So tangent theta, that will be y component divided by x component. So it is minus r omega square sin omega t upon minus r omega square cos omega t. This minus will be cancelled, r omega square will also be cancelled. Sin omega t upon cos omega t, it is tangent omega t. So tangent theta is equal to tangent omega t. It means theta is equal to omega t. So angle of acceleration with x-axis will be omega t. That angle was also omega t. But now there are two possibilities. Either this acceleration will be in this side or in this side. Either away from this center or toward the center. Because in both the cases, angle will be omega t. Now which one will be the answer? X component is minus r omega square cos omega t. That is, x component is a negative. So x component will be in this direction. Y component is also negative, minus r omega square sin omega t. So that will be in this direction. So resultant will be in this direction. This is x component of acceleration. It is y component of the acceleration. So resultant will be somewhere in between. So that will be direction. So acceleration will be towards the center of the circle, exactly towards the center of the circle. Under which condition? If particle is moving in the circular path with constant speed, in that case. So if a particle moves in a circular path with constant speed, In that case, acceleration will be toward the center of the circle and velocity will be tangent to the circumference. If particle is moving with accelerated motion, that is, it is not moving with constant speed. Its speed is changing continuously. At this point it has some speed, at this point it has some other speed. So one acceleration, centripetal acceleration will be toward the center, one acceleration will be in this side, so resultant will be somewhere in between. Due to centripetal acceleration, due to linear acceleration in that direction, so resultant will be in somewhere in between these two. So in that case, acceleration will not be toward the center of the circle. So that was all about the velocity and acceleration in circular motion. I will take a very small topic. We discussed about the angular velocity. Omega was change in angle upon change in time. In one complete rotation, angle traveled is 2 pi. In one complete rotation, angle traveled in radians is 2 pi, and time taken is called time period. So it takes capital T time. In capital T time, it travels 2 pi radian angles, so that will be angular velocity. 2 pi by T will be the angular velocity, and we know 1 by T is the frequency, so it will be 2 pi f. So angular velocity is 2 pi by T or 2 pi f. That was all about in this chapter. We have completed this chapter. So now you can solve all the numericals of this chapter. Thank you.